today we will discuss about this problem. This problem contains only one dependent energy source. So how to calculate the Thevenin voltage and Thevenin impedance of this circuit? In previous class I have already discussed how to calculate the Thevenin voltage and Thevenin impedance of a circuit consisting independent energy source. Number 2, consisting both dependent and independent energy source. Now this circuit contains only dependent energy source. So in this circuit, how to calculate VTH and ZTH? So if a circuit consisting dependent energy source, the VTH will be 0. How VTH is become 0, I will discuss using this problem later. Number 2, how to calculate ZTH or RTH? To calculate RTH, you have to insert or connect 1 volt DC source across this open circuit terminal. Okay, so using this problem I will calculate VTH and ZTH. So let's start. So this is the problem. So this 1 ohm resistance is open circuited. So current through this open circuited terminal is 0. So the current through this resistance 1 ohm is 0. That means Ix equals to 0, because since 1 ohm resistance is connected to open circuit terminal, circuited terminal. So this 1 ohm resistance is connected to this open circuit terminal A. That's why current through this resistance 1 ohm is 0. If Ix is 0, then this dependent voltage source will be off. So dependent voltage source will be off because Ix is 0. So this will be 0. So voltage alpha Ix must be 0. That means this is off condition. So this circuit does not contain any active source. Okay, if Ix is 0, that means this is off. So if this is off, there is no voltage source, active voltage source in this circuit. That's why VTH equals to 0, since the circuit does not contain any active energy source, because this source become dead because of the Ix is 0. So why the Thevenin voltage of a circuit consisting dependent voltage source or dependent energy source is 0, this is the explanation. Okay, so this is the way how to calculate the VTH of this circuit. Now you have to calculate the RTH or ZTH. So to calculate RTH or ZTH, you have to connect 1 volt DC source. You have to connect 1 volt DC source across this open circuit terminal. Okay, open circuit terminal. Now this is a node. Suppose this node is X. This node is X. So this node voltage, suppose X. This node voltage, suppose X. Now applying KCL at node X. At node X. So current through this branch will be Vx minus alpha x divided by 1. So Vx minus alpha ix divided by 1 plus current through this 2 ohm resistance is equals to Vx divided by 2 plus current through this 1 ohm resistance is Vx minus 1 divided by 1 must be equals to 0. This is 1 volt. So Vx minus 1, the node voltage of node A is 1 volt. So Vx minus 1 by divided by 1. Okay. So this is the KCL at node, KCL equation of node X. So this is equation number 1. Now if I take this branch, that means XA branch. So from XA branch we can write that this is direction of the current Ix is along this direction. So this voltage is greater. So 1 minus Vx divided by 1 is equals to Ix. So current through this junction is along this direction. Okay, so this node voltage is 1 volt and this node voltage is Vx. So 1 minus Vx divided by 1 equals to Ix. So Ix is or 1 minus Vx equals to Ix, or Vx is equals to 1 minus Ix. This is the equation number 2. So Vx equals to 1 minus Ix. Now if I put the value of Vx from equation 2 into this equation 1, then I will get this is Vx. So Vx is 1 minus Ix. So this equation will be 1 minus Ix minus alpha Ix divided by 1. Okay, so this term become this. So Vx equals to 1 minus Ix minus alpha x divided by 1. Now plus this is Vx equal to 1 minus Ix. So 1 minus Ix by 2, and this is Vx. So Vx is 1 minus Ix. So plus 1 minus Ix minus 1 by 1 equals to 0. This is the equation. Okay, so from this equation we can write that, or this is 2. So it will be 2 minus 2ix minus 2 alpha ix plus 1 minus ix plus 2 minus 2ix minus 2 equals to 0. So now 0. So now ix is, this is ix, this is ix, this is ix, this is ix. So this is minus 2, minus 2, minus 4, this is minus 1, so minus 5ix. So minus 5ix. And this is minus 2 alpha ix. This is 2, this is 1, 3, this is 5 minus 2, that means 3, plus 3 equals to 0. This is the equation. So minus 5ix minus 2ix equals to 3. Now if this is minus, if I take minus ix common, so this is, if I take ix is common, so minus ix is common, then it will be 5 plus 2 alpha is equals to minus 3. So this minus will cancel, so it will be, or ix equals to 3 divided by 5 plus 2 alpha. So this is the ix. This is equation number 3. So ix is 3 divided by 5 plus 2 alpha. Now you have to calculate RTH. What is the RTH? This is the ix and this is the VTH is 0. Now we have to calculate RTH. Now RTH equals to, this is the ix, so voltage RTH equals to V equals to IR, so IR equals to V by I. So this is V by I. So the V is 1 volt. I have employed this 1 volt DC source, so this is 1 volt, and this is ix of the circuit is ix. So this is ix is 3 divided by 5 plus 2 alpha, so it will be 5 plus 2 alpha divided by 3. So it is the Thevenin impedance of this circuit. So if I want to calculate the RTH of a circuit, of this circuit, I have to calculate this ix. So this ix is from this voltage source 1 volt. So the equivalent voltage across these two terminal will be this voltage divided by this current. So this voltage is 1 volt and this current I have already calculated for this circuit is 3 divided by 5 plus 2 alpha. That's why the RTH equals to 5 plus 2 alpha by 3. So in this way you can calculate the RTH and VTH of the circuit consisting only dependent